When today people are first confronted with the idea that the geocentric system of days gone by is actually a perfectly viable scientific model of the universe, they are, of course, stunned beyond belief. They find it incredulous that someone from modern times could even entertain, much less accept, that the Earth is in the center of the universe and all the heavenly bodies revolve around it on a daily basis. They have been conditioned since childhood that the two scientists, Nicholas Copernicus and Galileo Galilei, finally set the record straight and showed us with indisputable proofs that the Earth goes around the Sun and not vice versa. Yet recent polls tell us that at least a quarter of the population in the United States and a third of Europe still believes that the Sun revolves around the Earth. Why is that the case if science has proven that the Earth revolves around the Sun? One answer is that a sun revolving around the Earth is precisely what they see with their eyes each day as the sun rises in the east and sets in the west. No one who has seen the beautiful red, orange, and pink hues of the sun just about to dip into the horizon can deny that his eyes see the sun move and his feet do not feel the earth moving beneath him. Likewise, they also see the moon and the stars traverse the sky from end to end once per day. Time-lapse photography of star streams show quite vividly that the stars make giant concentric circles in the sky every night. In the 1960s, the rock band The Beatles wrote a song titled "The Fool on the Hill." One of the lines says, "But the fool on the hill sees the sun going down, but the eyes in his head we perceive the world around us and what, precisely, is moving around what." The rest of the song's lyrics lead to a haunting question. Who exactly is the fool? Is it the one who sees the sun going down and concludes it is really the sun that is moving? Or is it the one who sees the sun going down and thinks it is actually the world spinning round? Prior to the days of Copernicus and Galileo, one was thought to be a fool for believing the Earth was spinning round. 100 or so years after them, one was thought a fool for believing the sun revolved around the Earth. One might think that after so long a time after Copernicus and Galileo, including an even more famous scientist of that era, Isaac Newton, who had even more alleged proof about what was going around what, we should have long settled that seemingly basic question. But the astounding fact is, as modern science has advanced since that era, it candidly admits that it cannot give us any certainty on that very question. Indisputably, the world's greatest scientist, Albert Einstein, hinted at this newfound dilemma in one of his statements in 1938, saying,
"Since the time of Copernicus, we have known that the Earth rotates on its axis and moves around the Sun. Even this simple idea, so clear to everyone, was not left untouched by the advance of science.
Later in that same book, The Evolution of Physics, Einstein showed just how the advance of science had touched upon the presumption that the Earth is going around the Sun. Science had touched upon it in a most dramatic way, since Einstein, by his own scientific discoveries, was forced to admit the uncertainty when he said,
"The struggle, so violent in the early days of science, between the views of Ptolemy and Copernicus would then be quite meaningless. Either coordinate system could be used with equal justification. The two sentences, the sun is at rest and the earth moves, or the sun moves and the earth is at rest, would simply mean two different conventions concerning two different coordinate systems."
As we can see by the very title of his book, The Evolution of Physics, the interesting irony of Einstein's statement is that physics certainly did evolve after Copernicus and Galileo. When Einstein first entered the scientific arena in 1905 with his famous paper espousing special relativity, it was written for the express purpose of countering about a half-dozen experiments conducted in the 1800s that, by very straightforward evidence, showed it was the Earth that was fixed and the sun and stars were revolving around it. One scientist, Lincoln Barnett, who even had the foreword of his book written by Einstein, said rather frankly about these experiments,
"It was a serious dilemma, and one that split scientific thought for a quarter century. Many new hypotheses were advanced and rejected. The experiment was tried again by Morley and by others, with the same conclusion. The apparent velocity of the Earth through the ether was zero."
The experimental evidence then prompted Barnett to remind us that
"We can't feel our motion through space, nor has any physical experiment ever proved that the Earth actually is in motion."
Other scientists saw the same evidence, but just couldn't bring themselves to consider that perhaps, just perhaps, the Earth was at rest at the center of the universe with the sun and stars revolving around it. As physicist Arthur Otis put it,
In the effort to explain the Michelson-Morley experiment, the thought was advanced that the Earth might be stationary. Such an idea was not considered seriously, since it would mean in effect that our Earth occupied the omnipotent position in the universe, with all the other heavenly bodies paying homage by revolving around it.
Speaking for the science community of Einstein's day, historian Bernard Jaffe likewise describes their consternation over the results of these experiments.
The data were almost unbelievable. There was only one other possible conclusion to draw, that the Earth was at rest. This, of course, was preposterous.
Another scientist, Adolf Baker, expressed the same sentiments.
Thus, failure of Michelson and Morley to observe different speeds of light at different times of the year suggested that the Earth must be at rest. It was therefore the preferred frame for measuring absolute motion in space. Yet we have known since Galileo that the Earth is not the center of the universe. Why should it be at rest in space?
Even Albert Michelson, the famous scientist who conducted many of these experiments, couldn't avoid their implications, as he noted in these words of his 1881 peer-reviewed paper.
This conclusion directly contradicts the explanation of the phenomenon of aberration, which has been hitherto generally accepted, and which presupposes that the Earth moves.
Even scientists in the 21st century admit we cannot say with any certainty that the Earth is moving. Physicist Julian Barber, well known today in scientific circles, said this astounding statement in his 1989 book, Absolute or Relative Motion.
Thus, even now, 3.5 centuries after Galileo's condemnation by the Inquisition, it is still remarkably difficult to say categorically whether the Earth moves, and if so, in what precise sense.
But despite the difficulty of proving it, they were all quite confident that the Earth revolved around the Sun and rotated on an axis, since they have all been in the age of the Copernican revolution for almost 500 years. Turning back was, and still is, inconceivable to most people. Copernicanism is as foundational a belief as the fact that birds fly or that gravity holds us to the ground. Considering the devastating intellectual, political, cultural, religious, and scientific upheaval a motionless Earth in the center of the universe would have on our modern society, hardly anyone wants to allow the experimental evidence to be interpreted to give it any credence. But short of positive proof, something had to be done in the face of all the experiments that were showing the Earth was standing still in space. Something that would allow the science community to show that it was diligently addressing the empirical evidence, but at the same time seeking to lessen the possibility of a central and non-moving Earth so that mankind could continue to believe what they had believed for the previous 500 years. In the face of these experiments, it took about a quarter-century of proverbial head-scratching before the science community could produce at least one plausible explanation for why Dr. Michelson's 1887 experiment made it appear as if the Earth was standing still in space.
There are only a handful of experiments in physics that completely transformed physics. At many people's top of the list would have to be the Michelson-Morley experiment. It was an experimental advance in technology that transformed science. Not only physics, but science.
If the Earth is moving through the ether, then light waves going in one direction relative to us should travel at a different speed than another direction. It's like if you're in a fast-moving river and you're swimming along with the current, you're swimming much faster relative to the shore than if you're swimming against the current. So what the Michelson-Morley experiment was designed to do was measure the speed of light in one direction versus another direction to see how fast we're moving through the ether.
That task was left to a patent office worker who, in those years, more or less did physics in his spare time. His name was Albert Einstein. Confronted by its puzzling results, Einstein candidly admitted that it was none other than Albert Michelson's experiments that led him to invent his special theory of relativity in hopes of solving the problem. If you ever wanted to know where Einstein's relativity came from, here is the answer. In a speech in Kyoto, Japan, Einstein stated,
"Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect if we admit Michelson's null result as a fact. This was the first path which led me to the special theory of relativity."
Hence, to save the world from having to turn back the scientific clock by 500 years, Einstein invented the theory of special relativity to provide the world with at least one plausible answer to what had come to be the most important question and the most intractable problem of the 20th century, if not of all time. Namely, does the Earth go around the Sun, or does the Sun go around the Earth? If the Earth revolved, that meant it was just like any other planet that went around the Sun, with the Sun going around other stars and those stars going around other stars, in an endless cascade of circles. Altogether, it meant that the Earth was somewhere out there in the remote recesses of space, tucked away, as Carl Sagan told us, in some forgotten corner of a universe with no rhyme or reason to its existence. For Sagan and his colleagues, an Earth going around the Sun gave room to the possibility, however remote, that other universes had been here for an infinite time and that ours started in a Big Bang, which could then evolve to the point that it produced biological life on Earth and could do so on any similar planet in the universe. In short, it meant the Earth was not really significant at all. It was just one more rock on which moss grew.
Copernicus told us that we're not the center of the universe. We're certainly not the center of the solar system. The sun doesn't go around the Earth goes around the sun.
That's the Copernican principle, that if we are not really special, then this gigantic universe of ours doesn't care about us. We are nothing, absolute nothing.
But if the Earth was fixed in the center of the universe, and the sun and stars went around it every day, this inevitably meant that someone with a capital S, much bigger and better than humankind, put it in that most special place of the universe to be the apple of his eye. It would also mean that mankind did not get here by time, chance, or a huge explosion, for no one thinking logically would dare to pose the absurd proposition that Earth could occupy the center of the universe by random happenings. The stakes were indeed high. The very significance of the human race laid in the balance. If Einstein and the rest of agnostic society were going to solve the problem of getting Earth and its creator out of the center, they had to come up with an ingenious solution. As he labored in his patent office in 1905, Einstein was confronted with the fact that the 1887 Michelson-Morley experiment, and all other experiments both before and after, failed to prove the Earth was moving. This fact made Einstein admit that,
"Since then, I have come to believe that the motion of the Earth cannot be detected by any optical experiment."
But since Einstein was philosophically devoted to Copernicanism just like everyone else of his day, he finished his sentence with,
"Though the Earth is revolving around the sun."
As such, Einstein did precisely what a scientist is not supposed to do. He began with an unproven conclusion, that is, that the Earth is revolving around the sun, and then set to work backwards to make the evidence fit the conclusion. But doing so was not going to be easy, which is always the case when one is trying to fit a round peg in a square hole. The only way Einstein could give some semblance of scientific credibility to the conundrum created by Michelson's experiments was to reinvent physics from the bottom up, and that he did. Instead of interpreting the experimental evidence at face value, that is, by concluding that if the experiment showed the Earth wasn't moving, then the Earth wasn't moving, Einstein posited a clever alternative. He said that we should not look at Michelson's experiment with our unaided eyes, but we should don a pair of his new relativistic glasses. These new glasses would essentially allow Einstein to make it appear that the measuring device that Michelson used had altered during the experiment, and it was thus responsible for making it look like the Earth wasn't moving in space. And if that was the case, then even Michelson couldn't have known that his results were skewed by his altered yardstick, since without the new glasses, Michelson, as Einstein put it, would come to the wrong conclusion. In reviewing the series of events that led Einstein to his ingenious solution, if we were to reword the lyrics to "The Fool on the Hill" to fit what Einstein proposed, it might look something like this. The fool on the hill sees the Earth fixed in space, but the eyes in his head see the Earth spinning round. It was to this axiomatic conclusion of a moving Earth that all men, led by Einstein, were intent to follow, regardless of the scientific evidence pointing the other way. In a word, Einstein accomplished the astounding feat of making it appear the Earth was moving by convincing the world that some heretofore unheard of phenomenon that he dubbed length contraction was occurring whenever Michelson performed his experiment. As such, Einstein convinced the world that every time Michelson and his colleagues tried to do an experiment to prove whether the Earth was moving, nature conspired against them, as it were, and kept shortening their measuring devices and made it appear the Earth wasn't moving. Was this the answer of the fool on the hill? As noted earlier, from the remarks of some scientists, it appeared to be just that, since it was obvious to them that the easier and more logical answer was that the Earth wasn't moving and the measuring device remained the same length it had always been. Prior to Einstein, the first ones to propose that the measuring device may have shrunk during the experiments were the famous Dutch scientist Hendrik Lorentz and the Irishman George Fitzgerald. Lorentz and Fitzgerald proposed that since Michelson's experimental apparatus was tied to the Earth, and since everyone believed the Earth was revolving around the Sun at close to 20 miles per second, the substance of space, otherwise known at that time as ether, pressed against Michelson's apparatus and thus compressed the atoms so as to shorten its length. This solution, however, suffered from a clear case of the logical fallacy of petitio principii, otherwise known as using as proof the very thing one is trying to prove. To be logically sound, not to mention scientific, one cannot use as proof that the Earth is moving 20 miles per second around the Sun in order to prove that the Earth is moving 20 miles per second around the Sun. But at this point, with the pride and prestige of modern society hanging in the balance, neither the science community nor the rest of the world was as interested in being logically consistent as they were proposing a theoretical counter-thesis to how Michelson's experiment could be forced to provide them with the moving Earth they all wanted so badly. In his patent office during 1905, Einstein became privy to Lorentz's and Fitzgerald's bold new hypothesis, and he realized with them that the only way to adjust the results of Michelson's experiments so as to provide mankind with a moving Earth was to use the same assumption that the Earth was moving, and then claim that because of that movement, a shrinkage of Michelson's measuring device had to occur.
According to Prince Hubertus, Einstein said, "In view of such harmony in the cosmos, which I with my limited human mind am able to recognize, there are yet people who say there is no God. But what really makes me angry is that they quote me for the support of such views." Einstein had previously explored the belief that man could not understand the nature of God. In an interview published in 1930 in Virek's book Glimpses of the Great, Einstein, in response to a question about whether or not he believed in God, explained, "Your question about God is the most difficult in the world. It is not a question I can answer simply with yes or no. I am not an atheist. I do not know if I can define myself as a pantheist. The problem involved is too vast for our limited minds. May I not reply with a parable? The human mind, no matter how highly trained, cannot grasp the universe. We are in the position of a little child entering a huge library, whose walls are covered to the ceiling with books in many different tongues. The child knows that someone must have written those books. He does not know who or how. He does not understand the languages in which they are written. The child notes a definite plan in the arrangement of the books, a mysterious order, which he does not comprehend, but only dimly suspects. That, it seems to me, is the attitude of the human mind, even the greatest and most cultured, toward God. We see a universe marvelously arranged, obeying certain laws, but we understand the laws only dimly. Our limited minds cannot grasp the mysterious force that sways the constellations. I am fascinated by Spinoza's pantheism. I admire even more his contributions to modern thought. Spinoza is the greatest of modern philosophers, because he is the first philosopher who deals with the soul and the body as one, not as two separate things." End of quote. Now, I'm very curious how English native speakers are going to interpret this Einstein's assertion. Our limited minds cannot grasp the mysterious force that sways the constellations. If we suppose that Einstein hadn't been aware of geocentric truth, then we would have to ask ourselves, why in the world would he have used such a phrase, mysterious force that sways the constellations, given the fact that in heliocentric universe there is no swaying of constellations? Swaying of constellations would be only the apparent phenomena in heliocentric universe. On the other hand, if Einstein was aware of geocentric truth, which I believe he was, then his assertion would make perfect sense. Wouldn't you agree? Within heliocentric theory, the phrase mysterious force that sways the constellations makes no sense whatsoever, because the apparent phenomena of swaying constellations within the context of heliocentric theory would be the consequence of Earth's rotation on its axis, so that the only phrase that in heliocentric context would make any sense would be something like this: our limited minds cannot grasp the mysterious force that throughout hundreds of millenniums maintains Earth's rotation so amazingly stable. Mysterious force in relation to Earth's rotation, that makes sense within heliocentric context. But mysterious force that sways constellations makes no sense whatsoever within heliocentric theory.